Welcome to the second virtual lab. I'm going to be doing the empirical formula experiment. So we're going to be kind of applying some of the things we talked about in class, of how we can look at experimental data. If we can calculate the mass of all the elements, or the mass percentage, that would work too, of all the elements in a compound, we can calculate its empirical formula. Okay, so the first one we're going to do is procedure A, trying to find the empirical formula of magnesium chloride. Now, just from the name magnesium chloride, from your naming ionic compounds chapter, you should be able to predict what you think the empirical formula would be that would make this charge balanced if magnesium and chlorine are in their normal charges that we know they like to form from the periodic table. So we're going to be reacting magnesium, a little piece of magnesium ribbon. So here's my piece of magnesium ribbon. Okay, you might be able to tell it's pretty dark. Okay, it doesn't look real shiny and lustrous like we would normally expect a metal to. So the first thing I need to do is take a piece of sandpaper and just polish this real well. Okay, so I'm just going to take my sandpaper and get a nice shiny surface. So I'll show you the outcome of this rather than doing it live. And polish this up real good. So I'm just taking a little piece of sandpaper and trying to get all of that tarnished surface off so that I get a nice shiny strip of magnesium underneath. Okay, that ought to be good enough. Okay, so now, let's see if you guys can see this. You can see I've gotten a lot of this corrosion off. I broke my piece of magnesium in half, but that's not a big deal. Okay, I've exposed a lot of this shiny surface. I'm going to go over it one more time just to try to get it all nice and shiny. Okay, now the next thing it tells us, so it says to, in our procedure, get a piece of magnesium ribbon and polish it. So we did that. And then we need to measure the mass of our large evaporating dish and our watch glass. Okay, so our large evaporating dish looks like this. Okay, this is where I'm actually going to put my magnesium ribbon into for this first reaction. And the watch glass, we used watch glass last week. Okay, here's our large watch glass. This is just going to be sort of like a cover for our evaporating dish so that we make sure we don't lose any of our product in this reaction. Okay, so once that reaches a stable mass, you can go ahead and write that down in your report sheet. Okay, that first blank, I'm not going to do this for all of them, but that first blank under procedure A, okay, it says mass of large evaporating dish and watch glass. That's where this number will go. Okay, now it wants me to add, I should probably write this down too. I should probably write the number down too, although I can always watch the video later. So 98.4. It's kind of jumping around a little bit. 98.495 looks pretty stable. Okay, 98.495. Don't forget your unit. That unit is grams. Okay, my next step is to weigh this with my polished magnesium ribbon in it. So it should go up a little bit in mass. So make sure you record this number as well. Okay, then it tells you to find the mass of the magnesium ribbon by difference. Okay, the first thing you recorded was the dish and the cover, the dish and the watch glass. The second thing you recorded was the dish, the cover, the dish, the watch glass, and the magnesium itself. So if you subtract the first value you recorded from the second, that should give you the mass of just the magnesium all alone. All right. We will be right back with the reaction. The next step is to measure 3 milliliters of HCl using my graduated cylinder. So I have my HCl here in a little vial. Get this cylinder to where it's a little more level. And I'm ready to measure this. Okay, so that looks like about 3 milliliters. Volume of HCl is not super important for this particular reaction. Now I'll try to get this to where you can see it without getting HCl on my webcam. We wouldn't want that, now would we? Okay, hopefully we can kind of see what's going on here. And now I'm going to slowly add this. I'm going to slowly pour this HCl. Not doing this in the hood so that you can at least hear me a little bit and actually see this. Okay, I'm going to slowly pour this and let's watch what happens. Okay, so we can see, hopefully we can see, or maybe even hear some bubbling. There's also some gases coming off, and think about what that is. I'm going to go ahead and transfer this over to the hood. I'll show you what it looks like once it's done reacting. It's kind of hard to see the contents of this. Let me try to get some shade on it here. But this is really just full of liquid now. Okay, there's no metal left, just some tiny little flecks. It really just looks entirely like a clear solution. Let's see if I can get some shade on it. There you go. See what I'm saying? It's just a liquid in here now. There's no pieces of metal left. So, think about what's going on there. The next step I'm going to take is to evaporate all of the liquid off, or evaporate off all of the HCl. So I'm going to take this and put it onto a hot plate. Okay, can we see this? Maybe we're upside down, but we can see it. I'm going to put it onto a hot plate. I'm going to cover it so that if it's boiling very vigorously, I don't lose any of my product, because I need to know the mass of my product very, very reliably. So we're going to let this thing do its thing for a while. Okay, we're going to wait for all the HCl solution, all of the liquid, all of the water to evaporate, and then we're going to take our final measurements for procedure A. Okay, so let's move on to procedure B. Now that I have my mise en place ready, none of you guys speak French. Well, I don't know. Dr. Wysocki's section, maybe some of you guys speak French and you can call me out on my pronunciation. But now that I have all my stuff ready to go for procedure B, let's talk about it a little bit. Okay, so the first thing that we need to do is listed on the procedure in step 5. Okay, I need to get my crucible. So here's my crucible right here. Here's my crucible. Okay, it's just a little ceramic vessel that I'm going to heat my magnesium in. And it has this nice little lid that I'm going to put on top. Okay, it says in the procedure to give it a little tap, make sure we don't hear any weird noises that might lead us to believe that it's cracked. Sounds pretty solid to me. Okay, the next thing I need to do is get my Bunsen burner into the frame. I need to get my Bunsen burner ready to heat this, okay, because what I'm going to do eventually is I'm going to put my magnesium metal in here. Okay, we're on procedure B, we're making magnesium oxide. To make magnesium oxide, I'm just going to burn magnesium in the air, okay, and it's going to combine with oxygen from the air to make magnesium oxide. So I'm starting with magnesium and I'm adding oxygens to it. So I'm going to put my magnesium, which I have not yet polished, I'll do that in between takes here in a second. I'm going to put my magnesium in here, and I'm going to heat it really strongly up. Is this triangle going to hold? Let's make sure before we move on. I'm going to heat it like this, okay, with the magnesium in there until all the magnesium has reacted. And I'll know the mass of magnesium that I start with, okay, and then I'll know the mass of the magnesium at the end once it's burned, okay, and we'll talk about that, something odd about that in a second. I'll know the mass at the end when it's burned, And so just like the first procedure, since I know what I started with, I know the mass of just the magnesium, I know the mass of the end product. So in procedure A, magnesium chloride, procedure B, magnesium oxide, I'll be able to calculate my mass percent of each element, and I'll be able to find my empirical formula. Okay, but for starters, I need to make sure that this crucible, that I can get its mass really reliably. And right now it might be a little bit wet. Okay, there's water everywhere, especially when it's kind of humid, still sort of end of the summertime weather in Indiana. There's water everywhere, so we need to first drive all the water off of our crucible. Okay, so to do that, we're going to heat it with nothing in it. We're going to heat it really strongly for a few minutes until we feel pretty good about the fact that it's nice and dry. Okay, so here's the fun part of the lab that you guys don't get to do, which is lighting the Bunsen burner. Playing with fire in general is always kind of fun. You guys can't maybe see this real well. Oh, just a little bit. Sorry about that noise. Still can't. Well, you can kind of see a little bit there. Okay, my Bunsen burner's on. Got a nice big flame going. And now I'm just going to heat my crucible until it's nice and super hot and all of the water is gone. Okay, so I won't make you guys watch this part. You get kind of the abbreviated, it's like in the cooking show. You guys ever watch cooking shows? You guys can't really answer this, but you can think about it in your head. Okay, if you ever watch cooking shows, sometimes they'll like show you how to make some delicious casserole or something. Like, okay, we got everything ready. Now let's put it in the oven, and then they pull it right out of the oven like 30 seconds later because, it's TV magic. So we're going to do a little bit of TV magic here. We're going to come back when this thing has already heated all the water off and the crucible is already cooled, and I'll be ready to weigh my crucible with the lid to see how much that vessel weighs. It's really important that I wait until it's not hot anymore, though. Okay, you can never weigh things when they're hot because, one, you might warp the balance pan. You might mess up the balance and make it less accurate in the future. Well, my crucible's making noises on me over here. I don't like that. Maybe we're a little too deep in the flame here. What was I saying? You don't want to weigh things when they're hot because, one, it can mess up the balance, and two, the air currents of, the sort of convection currents that you get from having hot air surrounded by a mass of much cooler air, room temperature air, will cause the scale to fluctuate quite a bit. Okay, so we'll be back when we're ready to obtain our next mass. Now that our crucible has heated up and cooled off, hopefully we got rid of all the water in it, I'm going to weigh it. So crucible and lid. I'm going to weigh that. Make sure you write down this number. Okay, make sure you record all the decimal points that we're showing. Looks like it has stabilized now. 566. And now let's do the same thing, but put our piece of magnesium in there. So I'm going to polish my magnesium one last time. Get it really nice and shiny and reactive. And I'm going to coil it loosely. Tends to just work better when it's coiled loosely for whatever reason. And I'm going to toss that in there. Get it on the bottom here, nice and flush with the bottom, so it will react quickly, hopefully more quickly than just get it indigo. Okay, so now I got my magnesium in here. It's all over it again on me. Got my magnesium in here. I'll adjust it in a minute when I'm putting it on. Heat piece of magnesium, okay, and make sure you write down this mass. And then just like last time, we can find the mass of the piece of magnesium because we know the mass of the container it's in. Okay, the empty container, that's the first thing we measured. Now we have the mass of the container plus the magnesium. Okay, so let's go ahead and transfer this over and get this reacting. Well, if it's going to stabilize, it's going to stabilize for us. Okay, 6 to 8 is where we finally arrive. I don't know why it's hopping around so much, probably because of the fume hood that's running in here. Let's go ahead and start this reaction. So now we're just going to heat this really strongly with the lid open. Okay, the lid needs to be open for this first part because we need this to actually react with oxygen in the air. Once this starts reacting, so let me just adjust my camera a little bit here. Once this starts reacting, we should be able to see it. And I'm starting to see some evidence that it's wanting to go inside. So I'm going to hold this a little bit higher. Okay, once we see this catch fire, that's when we're going to want to cover it. With the lid still slightly askew so that it can get a little bit of oxygen. Okay, we're going to end up sort of removing the lid occasionally and replacing it so that it will still be able to get enough air. Okay, now we just wait. And there we go, we have liftoff inside. So now it's really important that we cover it. Okay, we can definitely tell it's reacting. Now it's important that we cover it so that we don't lose any little pieces of our product. Because if we lose some of the smoke out of the top of the lid, or if it really starts reacting really well and we lose a bunch of powder out of the top, then our data at the end is going to be no good because we will have lost some of our product. We won't know the mass of our product anymore. Okay? So I'm going to heat this for a couple more minutes until it's totally done reacting. Okay, I'm going to occasionally lift the lid off to let a little more air in and put it right back. And we're just going to let it do its thing for a little bit. Okay, so here, I'll show you guys one more time. Just going to take the lid off, let it breathe for a second, put it right back on. You can kind of see how it glows real brightly. Can you see this? I don't know. You can kind of see how it glows real brightly when I take the lid off. Okay, because it's mixing with air and actually has something to react with. Magnesium has to have the air to react with. Okay, so the only thing, oxygen is not the only thing that's in air. Right, there's something else that it could be reacting with, which is nitrogen. So we're going to have to take a step, once we think this is all done burning, it's stopped showing any evidence of reacting, we're going to have to take one more step to get rid of the magnesium nitride that forms. Okay, you should be able to predict what is the formula for magnesium nitride based on your charge rules and your naming like we had on the exam on Monday. But in case you forgot, there's a table at the very end of the lab report that has the formulas for all the relevant things that you need to know for today. Okay, for example, where is my page? For example, it tells you the formula for magnesium nitride. Okay, it doesn't tell you the formula for magnesium chloride or magnesium oxide because that's what we're trying to figure out today. But it tells you the formula for magnesium nitride. Okay, and that forms when oxygen reacts, when the magnesium reacts with air. Okay, so we're going to just let this heat strongly. So I'll come back in a minute once this is done reacting, and I'll talk about how we're going to get rid of that magnesium nitride so that we're sure the only product we have is magnesium oxide. We are now at the point where it's not really burning anymore when I have the lid off. So let's try to show this without ruining my webcam. Okay, it's kind of glowing red at the bottom. It's kind of hard to see. It's kind of glowing red at the bottom, but the metal itself is no longer burning, it's no longer flaming. So we're going to heat this strongly for about 5 minutes. Okay, I'm just going to leave it like this. Nice strong flame from my Bunsen burner. I'm going to heat it like this for 5 minutes, and then I'm going to add some water to it. Okay, now it's really important when I add the water. Well, first of all, why am I adding water? The water is going to react with magnesium nitride to give me two products. Magnesium hydroxide and ammonia. Okay, so the whole point of this was to convert the magnesium nitride into magnesium oxide, It turns out once I get magnesium hydroxide, if I just heat that really strongly, it will drive off one more molecule of water, and that will give me my magnesium oxide product at the end. So once this is totally done reacting, I'm going to heat this for like 5 minutes, and once it's done, I'm going to let it cool for a little bit, and then add a few drops of water. Okay, now why do I need to let it cool? What happens if I take my dropper, and this is still super hot, and I put some water in straight in there? Okay, what do you think is going to happen? Well, what's going to happen to the water when it hits the super hot crucible is it's going to evaporate like instantly. And when it evaporates, it's going to create a bunch of gas. And the effect that that's going to have on all my little finely divided pieces of ash inside the crucible is it's going to blow it, kind of volcano it all over the place, right? It's just going to go all out of my crucible. And then I got to start my experiment over because I don't have my product contained anymore. I can't find the mass of it. Okay, so that's the next step that we're going to do once once I let this heat for another minute or two. I'm going to let it cool, and when it's cool, we'll come back and we'll add water to it. Crucible, it's kind of hard to tell from the perspective here. Crucible is up here, and everything is nice and cool inside now, or pretty cool anyway. Remove this, it's not right in my face. And we're ready to add some water to this. Let me try to show you what the contents look like at this point so you can have an observation for that. Basically, what we got is a bunch of gray and white powder. Okay, there's no shiny metal pieces left. It's all just sort of gray and white powder. It may not be totally reacted, okay, just based on the fact that some of these pieces of gray are pretty dark. May indicate that there's still some magnesium metal in here, but that's okay. We just kind of want to collect some data and work it up and see what we get. So let's add a couple of drops of water. Okay, I'm going to go into my squirt bottle with my dropper. You can see it, nothing. If I did this right, nothing exciting should be happening. Okay, I don't want to see anything happen here. All I want to do is gently moisten everybody in here, because I want, if there's any magnesium nitride, I want the magnesium nitride to see some of this water. Okay, so it can then be converted over into magnesium hydroxide and then magnesium oxide. So what I got in here is a nice little soupy slurry of stuff. And now I need to get all that water out again. So I'm going to heat it sort of gently, and I need to do this with the lid on because as the water boils it might start splattering. I just saw it splatter a little bit. So I'm going to heat it with the lid on. We're going to heat it gently for a few minutes, and then we're going to heat it strongly for a few minutes, and then we'll be ready to take our final mass and see what we got. Now let's see what's going on in procedure A over here. Let's see what we got with procedure A. Well, you would have been able to see it, but I just ruined it because I moved the watch glass, so we're not going to see that yet. We're going to wait. But we'll see it soon. Okay, so when we come back, we're going to look at our magnesium oxide, and then we're going to get the mass of it. Okay, so I'm going to let this heat gently for a few minutes. I'm going to heat it strongly for a few minutes to drive off all that water. The excess water that I added, and also the water that will be released by magnesium hydroxide in order to convert over to magnesium oxide. I'm also driving off or heating off all the ammonia that formed from the nitride. Okay, the magnesium nitride reacting with water gave us ammonia and magnesium hydroxide. So ammonia, NH3, it's like the sort of one of the things that smells really bad in cleaning supplies or some sorts of cleaning supplies. Definitely a really bad thing to mix with bleach. But it boils even lower temperature than water. Okay, so it's going to come off pretty readily when we heat this. So a few more minutes of heating, and then we will cut to the dried and cooled magnesium oxide product, and then we will weigh it. Now that our product is nice and cool, let's take a look at it first of all. Okay, can we see in here? It's just sort of this dust at the bottom. Okay, this sort of like grayish, dark gray dust. Okay, that's what our magnesium oxide product looks like. And now let's go ahead and weigh this entire setup and see what we get. So 35 point, fluctuating a little bit, 661. Okay, 35.66. Well, now it's saying 2. 35.662. We're going to stick with 662 grams. That is the mass of our crucible, lid, and magnesium oxide. So make sure you put that in your report sheet. Okay, and then you can find the mass of your product. Okay, so here's your report sheet. Get this in the camera. Okay, once you know the mass of your whole setup plus your product, you can find the mass of the product by just subtracting this mass of your empty container from the beginning. Okay, so what you should find, and really if you just look at the last two numbers that we recorded, okay, before we did the reaction, we had a mass of 35.628 grams for the whole setup. After we're done, we went up to 35.662. Okay, so the mass actually went up even though we burned our magnesium oxide. And again, if you think about why, I kind of touched on this earlier, at least I hope it was in the take that I ended up including in this video. If you think about this, okay, it makes sense because usually when we burn carbon-based fuels like paper or wood, they make a gas product. Okay, carbon, when you burn it, turns into carbon oxide or carbon dioxide, which is a gas. So when we think about carbon things burning, we think about them losing all their mass and just turning into smoke and just a tiny little bit of ash that's left over. With magnesium oxide, what's really happening is the magnesium atoms, okay, we have more solid than we started with. We have a larger mass than we started with. Because what's happening is the magnesium atoms are combining with oxygen atoms. Okay, so when we started off, we just had magnesium. When we ended, we had magnesium plus oxygen. Okay, so we know the mass of magnesium in our product is just whatever was the mass of magnesium we started with. And we know any additional mass that we've measured our product having at the end, okay, is just due to oxygens attaching to the magnesiums. So the difference between our starting mass of magnesium and our ending mass of magnesium oxide should just be the total mass of magnesium, or sorry, let me say that again. The difference between the mass of our magnesium oxide product and our magnesium that we started with, okay, the reason why it's gained mass is just due to oxygens. So the mass of oxygen is going to be the difference in mass between our magnesium oxide product and our magnesium starting material. Okay, and we'll do the same thing with procedure A. So my procedure A is almost done. I just need to let it cool, and then I'm going to come over and record that mass, and that will be the end of the video. Okay, then the rest of the activities, the rest of the calculations, exercises you can do on your own. Don't forget, Dr. Ross and I are available to help you on these virtual activities. We may not be available during the actual lab hour because it's kind of not really feasible for us to, or at least when I tried to do this, wasn't really feasible for me to be checking Discord for questions and answering them while also answering questions for the in-person lab. But do send us an email. Okay, if you have any questions on the virtual lab, we'll be happy to help explain things or schedule a time to chat with you about it. Okay, so that's the end of procedure B. You should have gotten that last mass, 35.662, for the mass of crucible, lid, and magnesium oxide. And that's, of course, 35.662 grams. Okay, so we'll come back and we'll finish procedure A, and then we'll be done with the video. Our magnesium chloride. Our magnesium has finished reacting with hydrochloric acid. And once again, it's like impossible to tell what I have here. There we go. That's much better. Okay, magnesium has totally reacted with the hydrochloric acid, and all I have left behind now is this white powder with some little flecks of gray in it, sort of. Actually, yeah, there's just a few little tiny flecks of gray. Most of what you guys are seeing from this shot is a shadow. Okay, so that really dark sort of coil-looking thing in the middle, that's just a shadow. There's just nothing there. Okay, so I just get a bunch of white powder. now that all my solvent is gone. So my last step is just to weigh this. This is for procedure A, don't forget. Okay, for procedure A, weighing the magnesium chloride product, the crucible, or not the crucible, the evaporating dish, and the watch glass. So measured mass of magnesium chloride, watch glass, and evaporating dish is 98.6. Give it a minute. This one's a little bit, this balance in particular can be have a little bit of fluctuation to it. But it was the only one that I could unplug and move over here. Okay, 98.689 is what we're going to go with. 98.689 grams. That's what it's stabilized at a couple of times. That's what we're going to call it. Okay, 98.689 grams. And just like I did before, I know the mass of the empty evaporating dish with just a watch glass and no product in it. That was the very first thing you should have recorded for procedure A. So then you can find the mass of the product. Okay, the mass we just wrote down is the mass of the product plus the container. If we subtract the mass of the empty container at the beginning, then we should get the mass of our product. Okay, and just like the magnesium oxide, we know that we started with some amount of magnesium, okay, and we ended up with a larger mass of magnesium chloride. We know the difference between those two is just due to chlorines now combining with the magnesium. Okay, so now you should have all your data that you need to finish this experiment. If you have any problems, just let me know. Or not finish this experiment, but finish your report sheet, do all your calculations, and calculate your empirical formulas. When you get your empirical formulas, okay, it's okay for this lab to leave one of the subscripts as not a whole number, because that will tell you which atom is a little bit too high or a little bit too low in our measurements. So when you're calculating your empirical formulas, just make it to where the subscript of magnesium is 1, okay, and then your oxygen subscript and your chlorine subscripts can be decimals. Okay, you might get magnesium oxygen 0.9 or magnesium oxygen 1.1, something like that. Okay, for the chlorines you might get a decimal as well. So just leave it like that. Don't convert it to something like magnesium 10 oxygen 11, because that's harder to tell how far off we actually were from the real result, or what the real formula of these two things, magnesium oxide, magnesium chloride. Okay, so you should be good to calculate your empirical formula, and let us know if you have questions.